How's it going, everyone? Euler Gonzalez here, exploring the RxJS, specifically the operators, and now that we understand what RxJS is all about, especially based around the idea of observables, which is how can we now deal a series of eventual values. So why this is important? Because as we now understand all of these abstractions, especially all of these tools that are now available in the language, to come up with some way to, or a pattern to help us solve this concurrency that happen in our applications, or these tasks that overlaps at a time. And this is something that is not new to JavaScript. Other programmers before our era, right, in the 60s and in the 70s, they already after the Second World War and after the 50s, for example, one of them is Brady Butch. They now have to deal is with how now we can decompose all of those systems, not only in an algorithmic way, but to decompose these huge systems in some small parts. Now, because as they did that with a small project, for example, that Michael Grady Butch described, which is, hey, how can we now to decompose these huge systems into a distributed computing these systems into a different pieces that can be handled by different computers. For example, in this telemetry integration, telemetry interconnection, telemetry interconnectivity. Oh my God! Again, because I wasn't back then, but this software, at least just to describe briefly, this evolution of software here with Grady Butch. Shout out to Grady Butch, bro. Absolutely.
The phrase I also use here is that all of modern computing was woven on a loom of sorrow.
Now, it's just describing is a little bit of the evolution of the field of software development.
The presenting problem for software systems was they were generally not distributed. They were largely monoliths. And
exactly, because those applications were most likely monolithic, not distributed. And now enter here, how can we now is deal with the software that are multi-language, software that is real-time, software that can run in different architecture or computer architectures. And also now, how can we deal is with the asynchronicity, or in this case, the things at some point they're going to fail.
How could we build larger and larger systems that were sustainable and economically interesting over time? Well, the golden age of that first golden age of software engineering began to change as we started to see the rise of distributed systems.
Fair use.
And that rise, again, happened not in the commercial world, but it happened in the defense world. The ARPANET was, funded by the government, funded by DARPA. I was, as I mentioned to you earlier, I got my first email address in 1979 when there weren't that many email addresses around. In fact, one small story there, when we had the ARPANET in the air, I was teaching at the Air Force Academy at the time. We had a little mimeographed document that listed the email address of everybody in the world. I think at that time there were a few thousand people, so we knew who everyone was at the time. It was pretty cool to go back. So the first distributed systems were happening in that domain. Indeed, back to Vandenberg, I worked on a system called...
The first distributed system was in that domain, in that sector, the defense sector. And here is when he's going to explain what was the work he did back then.
The telemetry integrated processing.
Telemetry integrated processes systems, something that we have here. All right. And anything that is telemetry is it means that how you can now control remote systems. Yeah, basically, is that telemetry integrated process systems use telemetry data to monitor and control remote systems. So that's something interesting because right now what we're doing in software is especially that. It's like how can we now out of this thing is to control is some of those applications that are hosted in any of this service provider, Amazon, IBM, or Google, or AWS, or Microsoft, right? And understand what is the challenge that we are going to deal with, especially as we write in this kind of applications in this distributed environment. So the challenge back then was
system, which was a close network of some 32 mini computers. Mini computers were beginning to be a thing.
again closed network, which is somewhat similar to what is we have right now, at least when you have to work for some of this big company, or when some of those big company actually now hosted all of this particularly research on Microsoft, Azure, AWS, Firebase, in or Google Cloud Realm, and how you can now collaborate, how you can make all of this distributed computing to collaborate to each other. So
thing. And so the problems of how do I deal with taking a larger system and breaking it up into multiple distributed parts was beginning to emerge as a problem. Hadn't reached the commercial sector yet. So the industry.
and right now this has reached to the commercial sector. So perhaps currently I'm working for a bank where they hire me because hey, can you do this? Do you know what this stuff needs to be done, especially with the application? This is the data that we want to show to our users as a bank, and we're using it now this specific technology, which is React Native. So because now we're dealing with this kind of problems that Grady Butch actually have to deal with back then, and also previous engineering and computer science and programmers, is about that. Is how do we deal now with these systems that are distributed? Okay, so you have a server and a database hosted in particularly network, or you have is your APIs in another particular area. So
began to see that there were limitations to what one could do with algorithmic decomposition. And so there were these pressures.
Interesting limitation with this algorithmic decomposition.
All around to try to attend to the next kinds of software that was distributed, software that was real-time, software that was multilingual, software that worked on a variety of computers. And I had to deal with all the normal aspects of distributed systems, which is they're going to fail at various times. And
Completely. So move on.
I've got communication issues and the like. So it led to a realization that we needed to think about software in very different ways. The other thing that was happening is in research, you saw the rise of languages such as Simula and Smalltalk, which were looking at the world in fundamentally different lenses. So here we are again in the late 70s, and again, I'm a 20-something. I was asked by one of my former teachers at the Air Force Academy, say, Grady, would you go help the Department of Defense figure out how to use this new programming language called Ada
Castle.
so we can apply it to modern software engineering techniques? Now, why was the government worried about this? By that time, software was a real problem for the Department of Defense, actually for all of the federal government, because there were several thousand languages in use that exploded because Fortran and COBOL were useful for some things, but not for all things. And so there was a decision made to build one language to rule them all, and that was the Ada programming language. Ada was far ahead of its time. It was a language that was influenced by Simula and Smalltalk and others, but it used the ideas of abstract data types from Liskov and Gauguin and others. It used the ideas of information hiding from David Parnas, all ideas that were very new at the time, but frankly are part of the atmosphere in which we breathe right now. And so as an industry, we really didn't understand the methodologies to make that work. Thus was born the Booch method. I was in 79 till about 81. I was going back and forth across the United States, helping the federal government and helping contractors try to apply this new language in new ways. And this was the beginnings of the second golden age of software engineering, in which it was not so much the complexity of the algorithms, but it became a systems engineering problem, systems that were dealing with distributed systems that were very new at the time.
So I'm making now a quick pause here, and this is exactly the reason why we are in today's video looking at the RxJS. Because great, now that we have to deal with this distributed computing and all of the challenge that we need to deal with, especially that algorithmic decomposition is not an approach, it's not a helpful approach to actually deal with this, and that's when we now have to combine this with the object-oriented programming and the distributed systems and the concurrency as well. This is huge. And again, just to make a quick recap of this, because now if we are able to look at the world through objects, which is a particular philosophy of how we can design systems here, it's like, hey, how can we not bundle this data and its functionality together, right? Which is from another video, right? So JavaScript, the hard part of object-oriented programming in JavaScript, that is now behind the scenes using the prototype object program. Oh my God, prototype object-oriented. But now here, how now we deal is with the concurrency in applications, the asynchronicity here. And there are several tools that we can use in JavaScript thanks to the hard works of all of the people that they have now deal with this in a very horrible way, and then realize that, hey, it'll be much more better, not only for us, but also for the community to now land these abstractions or tool in the language. So callbacks, since this is not relevant or specifically to the JavaScript, because if you're going to work with this, you now use this timer, all right, to defer tasks to be complete at some point in the future. So timer is something that is provided by the web platform, not the JavaScript, whether it is, but the platform in itself, the web or node. And there are several trade-offs when you use that. So for example, in version control, and they're not reasoned about. And now how also we need to deal is how we coordinate its time with all of these different responses, with all of these different tasks that need to be handled at some point in the future. So Thongs came here, which is a technique in programming to actually help us deal with the complexity of orchestrating time in our programs by eliminating time as a concerning factor. So you just provide everything that a function needs, and then you wrap that into a function, and by the time that you get that value, you pass a callback to get that value. So this is quite powerful, because even though this doesn't solve the problem of inversion control that callback has when you're using timers, all right? And now how JavaScript behind the scenes, the anatomy of this, it is made of the thread, which is a single thread, which means that is this small unit of execution that a program can have, and a program is just a executable files that are saved in disk, and once that is mounted on the main compute on the main memory, and run by a CPU, it becomes a process. So one of the important features of process is that process can run in a separate memory address. So different process, if one of them get corrupted or failed, it won't interrupt other processes, which is a great thing. And inside of this process, you can have is threads or multiple threads. Again, a unit of execution. Where now here you have things like program counter. Hey, at which line of the code I'm currently at? Stack. Hey, what is the internal memory that I want to use? And register. What is the set of instructions that the CPU exposed to me that I can run several instructions, whether it is arithmetic instructions or logic arithmetic or other kind of instructions here. But this is just to describe is the most common things that what a thread's anatomy looks like, and how now different language has a very different implementation of the threads. And in the case of JavaScript, this is made of the global function execution, where anytime you run a JavaScript or a function and create now this function or global execution context, which is made of the lexical environment, your line of code, as well as the scope, and the variable environment is like, hey, what are the variables that you're going to put in there, which is the heap, right? The call stack, which allow now to track at which line of the code is currently evaluated by adding all of these functions to that. And because you can preemptively interrupt the execution of a function, which is known as cooperate concurrency, which is a fancy term for this, because functions runs to completion, but it doesn't mean that you can add a new function inside of this another function, and when you call that function instead of a nested function, it add to the call stack, run to completion, or until you find another new function and add to the call stack, and so on and so forth. So the call stack, the heap, which is now memory is allocated, right? So variables and objects are allocated. And now the event-driven architecture, which is the callbacks, the promise, in this case, the callback and the microtask queue. The microtask has more priority than the callback. The event loop, which is the stack and queue coordinator, and the web APIs or Node.js API, which is this set of method that you can access in JavaScript depending on the platform that you're running, whether it's on the browser or on the server. So the idea of looking at that and describe that in JavaScript is because now we have is the anatomy, the vision to understand now why we are doing the kind of things that we do in our programs, especially when you write synchronous programs, user interface most of the time, in the case of UI specialists, and when you need to deal with the concurrency, this task that overlaps over time, callbacks is not enough to describe the complexity of what we need to deal in JavaScript, right? Especially writing modern JavaScript, not even thongs as well. And that's why we have also promises, which lands to the language thanks to the hardware to programmers that now one of them is Mark Miller and among other contributors that make that possible to land the promises these abstractions that we need to eliminate time as a concerning factor, wrapping around a wrap value. And promise help us now to deal with these eventual values. So this has also come from programming or functional programming. So promise, after all, this is our monads, but monads is just, I'm gonna describe that from one of the use case. It allows to describe is state change, right? So, because what is relevant in today's video is to look at promises, understand what promise is, what is the value proposition of that, what are the common methods that we can go with promises, all settled, raised, and any, and then how this tool now allows to represent is flow control and data flow, but still, even though that is solved the version control, we don't have the ability to run our code in a synchronous blocking sequential way, the way our brain works. Now, it means that generators now give us the ability in the language to describe this state machine, which is a series of flow from one state to another, to another, to another, and descriptively list out the transactions out, right? So we can write state machines in JavaScript, but that requires careful programming. You can combine that with iterators and callbacks. And iterators is a design pattern for stepping through typically a data set, and now is a flow control. All right. So with generator, we were able is to now mimic or make the behavior of async and await. So by using is now the generator as a message passaging, and also as the control flow execution using the iterator that is provide us, we actually mimic that behavior. So the idea here is to understand now how these tools are combined, and especially if you want to deal with or you want to understand now how async and await works behind the scenes. So this is great because it helps us now with solve is eventual value, single eventual value in a synchronous blocking sequential way, while gain trust that that has been done after we evaluate the next line in a single thread, right? So this is a great stuff, because now what happened, remember, we need to write this kind of async applications that communicate with different services, all right? And how can we now deal is with a series of eventual values, all right? So not only that a single source is giving us a single value, so for example, when you fetch a data using an HTTP request, okay, or an TCP connection, but also is how can we now is deal with these streams of data, get one of those elements and apply some transformation or path through a series of steps so we can distribute that in our system. And this is interesting because this is not only to understand how can we deal with these eventual values using observables. That's what observable allows to do, okay? Is give us the ability to now work with this unit of data, pass through a series of steps, and then distribute that, all right? Pretty much like in a spreadsheet. And here, because observables are not native to the language right now, we need to look at RxJS, which is now a library written by some smart folks at Microsoft that they have that particular issue, and now we can use that in JavaScript. So they pour that to different other applications or languages. Initially, they wrote that on Java, and then now in C#, and locally for us, we have that also in JavaScript. So all of this is just to describe now that briefly in this piece of code, this part of code of the RxJS, how can we create our observables? How can we test our observables? What is the most common way to create an observable? Whether it is similar like promise, when you create now the promise and then you pass the executor functions, or on the observable, when you say, hey, this is now the data that I want to, this is now the function that I want to pass as a constructor, similar the executor to promise. When you pass is the resolve and the reject. And now an observable you pass is now a subscriber, and get yourself familiar with the subscriber contract. This is rare, but important to know that at some point you might need to do that. And what is more relevant is that how can we now create streams of data or observables here, using now of and from to create or single values and objects, or from promise, or from promise and iterators, generators, and array-like syntax, right? So we also look at another common operators, for example, like from events, bind callbacks. That was quite interesting. So to get ourselves familiar that, well, we can now subscribe to that, and also the from fetch. So, and then now the intervals and timers. So here is when we're going to create our observables, not synchronous observables, which is something we have to create right now. Okay, pretty much like an array. When you fix that, right, you know the length of this. But what happened with this series of eventual value that happened at some point in time, right? And then we want to subscribe to that. So we look at intervals and timers. Pretty straightforward, right? You can create now is your interval for that. The difference between intervals and timers. So intervals now happen is a regular interval, right? Where now timers it emits after a certain amount of time. So for example, here you can say, let's go to actually put that at test, you know. Say cloud code sandbox here. That's right, perfect, awesome. Generative AI, I wouldn't jump that directly. All right, there you go. This of course will work as expected, but I just want this to now test is, well, this is the index, right? Let me put this into another file and say, hey, this will be called now is binding .js, right? Paste it here, all right. And well, the timers, you say timer, right? So with timer here, we can say, hey, I want to now is create a timer, and it means that this operation will trigger after or this. So it's going to emit after a certain amount of time, only once. So the sort of difference between timer and interval is that timer happens once, whereas intervals are a series of time. So to actually now show you that this is true, timer is observable. You say, hey, timer, right? And I want you to trigger this now 5,000 after 5 seconds. Or let's gonna put this after 3 seconds, much better. And I want to now is have the now, date now. You say, hey, date, give me the date now, right? And well, I want to subscribe to that, right? So by the time you subscribe, you create now a new subscription, which means that you create a new instance that is going to now hook up to that event source, and anytime an event is produced, it creates a new promise out of this. So this is another way of how you can think of observables. This is now hook up to an event source. So an observable is like, so an observable is like, is a model that is hooked up to an event source that produces promise every time an event comes through. Now, it means that we say, hey, we want to get the time here, okay? And well, I just want is to now console log is the time minus the date now, right now, right? So if we now run this, oh, of course, we need to do that in a way that is, yep, yeah. We need to say something like this. We can also is show the time, right? So you can see that after 3 seconds, it's gonna run that. Of course, this is 0, but it actually run after 3 seconds. So we say, hey, give me is the date. So you say day, or in this case is the current date, exactly. So the date dot now, the current date minus the date, right? And you're gonna see this, right? But again, this is only runs once. So now that we know the difference between the timer and interval, okay, we went on to also say, hey, you know what, you should unsubscribe to stuff, man. Especially if you use, for example, interval. Especially if you use interval for that, right? And then you say, hey, this is interval and interval, right? And now this is going to be thrown after 3 seconds, and then it's going to have 6 for that, 9 for that. And you may wonder why this doesn't give you is now the exact time, well, because there is a subtle difference between when the function is called and when the function is executed, but again, it actually is triggering is that. However, now how you want us to unsubscribe to this? That's a good question, right? How do you unsubscribe to this? Well, you not only hold is a reference to this, all right, but you say, hey, after an X amount of time, I want you to unsubscribe to run this. So let me now say, hey, this will be triggered now 1 second, right? And after an X amount of time, right? And after an X amount of time, I want you to now run that. So you say, hey, is this one? Say, all right, so the interval observable, I want to unsubscribe I want to unsubscribe that, all right, after 5 seconds. So because now we pass that, we say, hey, unsubscribe is unsubscribe, oh my god, yeah, it's like unsubscribe unsubscribe is not a function. Oh, interesting. Really? Interval unsubscribe is not a function. It's because I need to have is the reference of the subscription. Okay. Subscription. Oh, makes sense. Okay. Exactly. Okay. Not the observable, but it's the subscription. It's like, hey, stop the subscription here. And again, because it doesn't have the same time, you say, well, doesn't stop that after 5 seconds. But in any case, we get the idea. Now, with that, all right, the value proposition of using RxJS is to work with streams of data is that we have control of when and what we want to do some operations on that. Okay, that's the whole value proposition of working with this RxJS or observable, is that we know when and what we want to do some operations to that streams of data. So let's get into that, shall we? If we take a look at this, really? Oh, you got it. Okay. React Native version 3. What in the F is that? Oh, Enterprise UI. Might be here. Really? No, it's not here. Counter, portfolio, etiquette, intro. What? We don't have RxJS? Don't believe it. We don't have RxJS? I think you got it. God damn it. Okay. Okay, that was a quite interesting exercise here, you know? That was a quite interesting exercise. let me actually show you the code, which is this one. It was a very interesting exercise here. If we run here, and how we can now is combine is the events getting from the DOM, and then now create is a timer from that, and then anytime we want to pause that or stop that, we just only unsubscribe to that, which is quite interesting. npm run def. No, I think it's package JSON here, and then we say, what is this? What is this? What is this? npm run. Oh, it is no. npm run UI. Okay. When we go to the basic counter, like this, follow me here. So when we start here, it actually starts counting here, right? And when we pause, exactly, we unsubscribe to that. And because we unsubscribe to that, and by the time we click here, we are now subscribing is to this new event source, this new observable. So we start from 0. You know, that's quite interesting. So good. And again, this example, yeah, this is a very silly example, but a very interesting one, right? Now, let's get into the operators.
So your mission is to making streams is fine and good, and we've done some stuff with those streams. We have manipulated the DOM predominantly. We've occasionally logged to the console. But as these events come through, the ability to do stuff with them is, I think, where we start to find the power of RxJS. So really, when we talk about operators, we're going to talk about this like it's effectively a story in 3 parts. Part 1, we're just going to talk about some of the basic like data manipulation operators, right? These are not dissimilar from what you might be familiar with like in Lodash or even on the array prototype. It harkens back to the very beginning of this when I said, when I quoted from the RxJS documentation that RxJS is like Lodash for events. Well, yeah, that also means that like some of the methods like Lodash has are common for RxJS as well. We'll start with these. A lot of them like will seem somewhat familiar, at least intuitive. But what I want you to pay attention to as we go through is the syntax. The syntax could be slightly different than what you might be used to like on an array. On an array, you can kind of chain the methods as you go through. The concept is the same, but the syntax is going to look slightly different, and for a very good reason I'll kind of explain along the way. So we will kind of start with this kind of Fibonacci sequence right here. Right? Now this one, as we kind of, like the question we had earlier, was like this one will go on forever. So if you were to just subscribe to this, you would lock up the main thread, and bad things would happen, right? So you would have to do something like this. You'd have to say like, okay, cool, I want a Fibonacci sequence of a certain number of iterations and then stop, right? But again, the promise of like RxJS is that we can take these streams and we can choose as the consumer when we want to start and when we want to stop, right? We don't need the interval at the time it's defined to know when to stop counting. We'll stop counting when we say we're going to stop counting. We kind of like take that control in our own hands at this point. So every observable on top of of everything else has this thing called a pipe method, and a pipe method takes one or more operators, right? And those operators kind of run through one after the other, and each one will manipulate the values that come through and pass it along to the next one. So similar to method chaining, also similar to you've used either pipe or chain in Lodash. In a lot of like functional programming libraries, there is some version of this. Where you can kind of just take a value and keep moving it along the way, manipulating it over time. Where RxJS gets interesting with this is not only can you like double a number, which is what we're going to start with and stuff along those lines, but you could also say like, cool, I want to like space these out over time, or I want to only take every nth value number, which is what we're going to start with and stuff along those lines. But you could also say like, cool, I want to like space these out over time, or I want to only take every nth value, or like if they're rage clicking on that button, wait until they chill out a little bit, and then we'll go respond with a request in a reasonable fashion before we slam our own API, right? And all of those kind of things giving us the ability to kind of control the flow. So we'll start with some of the basic kind of just operators for manipulating the data. Eventually, we are going to move into some of the ones where we kind of manipulate time a little bit and have rules based on kind of the time-space continuum and what we want to do. And finally, we'll look at some of the ones that allow us to kind of take multiple streams and kind of combine and control them.
Exactly, multiple string can I combine it with loader. This is where the value of all of this comes here. Is that how can we now, from our application, is to deal with this several incomes of data, right? And make it easy to work with. It's like, hey, I want to subscribe now to this observables, and this another one, and this another one, this another one, right? In other words, I want you now is receive data from the analytics or the user database or the payment methods, right? Or another useful thing is, I think this is quite more interesting, is in terms of streaming data. For example, is that, hey, now I want this to is download data, download or combine all of this data that I'm going to get from different sources, from different computers, and then now once I get that, well, pass through some sort of checks, for example. Oh, so
On top of of everything else, has this thing called a pipe method, and a pipe method takes one or more operators, right? And those operators kind of run through one after the other.
Okay. So those operators runs once after the another.
And each one will manipulate the values that come through and pass it along to the next one. So similar to method chaining, also similar to you've used either pipe or chain in Lodash. In a lot of like functional programming libraries, there is some version of this where you can kind of just take a value and keep moving it along the way, manipulating it over time. Where RxJS gets interesting with this is not only can you like double a number, which is what we're going to start with and stuff along those lines, but you could also say like, cool, I want to like space these out over time. Or I want to only take every nth value, or like if they're slam, but you could also say like, cool, I want to like over time. In a lot of like functional programming libraries, there is some version of this where you can kind of just take a value and keep moving it along the way, manipulating it over time. Where RxJS gets interesting with this is not only can you like double a number, which is what we're going to start with and stuff along those lines, but you could also say like, cool, I want to like space these out over time.
A useful thing with RxJS is to say space things over time.
Or interesting with this is not only can you like double a number, which is what we're going to start with and stuff along those lines, but you could also say like, cool, I want to like space these out over time.
Space this over time.
But you could also say like, cool, I want to like space these out over time.
Space these over time. I want to space this over time. I want to space this out.
Gets interesting with this.
Space this out over time.
Double a number, which is what we're going to start with and stuff along those lines. But you could also say like, cool, I want to like space these out over time.
Space this. I want to space this out over time. Interesting. Space this out. Because I become inattentive. Arrange with space. Space out. Space this out. Space this out over time. Space this out. Space this out for me. Wait, what?
or I want to only take every nth value, or like.
So a useful thing with RxJS is to space this out over time, or take every nth value, or take every nth value.
If they're rage clicking on that button, wait until they chill out.
If they are RAM,
These out over time, or I want to only take every nth value, or like if they're rage clicking on that button.
If they are rage clicking on that button, wait until they chill out a little bit. If they rage click on that button, wait until they get chill out a little bit.
Wait until they chill out a little bit, and then we'll go respond with a request in a reasonable
Wait
fashion.
until they chill out
before we slam our own API, right? And all of those kind of things, giving us the ability to kind of control the flow. So we'll start with some of the basic kind of just
before we can
data.
start.
Eventually, we are going to move into some of the ones where we
hammering,
kind of manipulate time a little bit and have
or
rules
API.
based on kind of the time-space continuum of what we want to do. And finally, we'll look at some of the ones that allow us to kind of take multiple kind of manipulate all the flow. So we'll start with some of the basic kind of just reasonable fashion before we slam our own API, right? And all of those kind of things, giving us the ability to kind of control the flow. So we'll start with some of the basic kind of just operators for manipulating the data. Eventually, we are going to move into some of the ones where we kind of manipulate time a little bit and have rules based on kind of the time-space continuum of what we want to do. And finally, we'll look at some of the ones that allow us to kind of take multiple streams and kind of combine and control them as we go along. So we'll start to play around with this in a second. But if we look, we have this one called take, right? And take will solve that initial problem that we had earlier, right? Where we had an infinite generator that was going to spit out values forever, right? It can still be its infinite self. We're just basically saying, I'm going to take 10 values from you. I'm going to unsubscribe, right? After that, we're done here. I'm going home, right?
Because a certain number of values.
You don't have to have all that logic.
A certain number of values.
But you can have it in whatever is consuming it.
Go back
you
to
can
home.
choose how many values it wants, and you can kind of begin to manipulate, so on and so forth. All right, cool. The other one, its friend, is skip. Skip will skip the first number of values. This one is dangerous with a Fibonacci sequence because it is infinite, so you gotta be careful. We have other ones like take while and skip while, which will very much act like a filter function where they'll go through and they will take all the values up until you hit 200, or skip for a while and then take 4, so we don't have the infinite problem. And you can see we can chain them. Where it becomes a little bit different is, we'll look at pop quiz in a second, but I want to, this slide's a little bit bigger, so I want to look at the syntax here. Is instead of method chaining, right, you kind of pass them all in as individual functions, right? And even if it doesn't take any argument for a while and then take 4, so through, gotta be careful. We have other ones like take while and skip while, which will very much act like a filter function where they'll go through and they will take all the values up until you hit 200, or skip for a while and then take 4, so we don't have the infinite problem. And you can see we can chain them. Where it becomes a little bit different is, we'll look at pop quiz in a second.
Skip values as long as certain condition is met.
Is instead of method chaining, right,
from conditions,
you kind of pass them all in as individual
take all these values,
right? And even if it doesn't take any arguments, you still call it as a function. That's mostly to keep the
and then take care of bye-bye. Let's go to home.
The reason for this is by breaking
ignore the
all
first,
operators
however,
out into
many
their own
values
functions that you can import one at a time. You can use tree shaking in your bundling tools, right?
Is pipeline and or
it say, hey, skip while, because skip say, hey, ignore the first 100 values, all right? You say, hey, ignore the first 100 values, and then take while here by saying, hey, now take this particular value. It's because it's as long as there, if one of them, if the first doesn't get triggered, the second doesn't.
Arbitrary many. Does
Exactly.
it, or is it one of those weird like FP functions that has like a definition for 1 input and 2 and 3 and 4, where you max out eventually?
I haven't looked at the types to see where this ends. Like the JavaScript implementation of itself, the JavaScript implementation of it, like will allow for n arguments. Whether like if anyone who's tried to like type a function that takes an unknown amount of arguments has seen that the types are usually just more and more types, right? And if you're using this with TypeScript, you know, each one, like if you return a different value, the next one has to be able to receive it, right? So like you start out with that initial value, in this case from the Fibonacci sequence, it would be a number, right? If you map it into a string and then you try to do a number thing with it, TypeScript will get very angry with you, and TypeScript will assume when you subscribe you're getting whatever the last thing out of that pipe was. But the actual type definition, my gut says, I've looked at Lodash's, where it is simply, here's a type with 1 argument, here's 2, here's 3.
I just
here's
looked
4.
and it goes from 1 to 9. So
9.
you can put up to 9.
You can put up to 9 before TypeScript gives up on you. But the JavaScript implementation, you should be able to have effectively an infinite number. I think the only color I'll add to that question is 9 in a row, like past that, like there's probably a reason they stopped at 9, right?
The only
Not to say
color
you
that
won't have
that'll add.
things where you have child observables, so on and so forth, but like after 9, you can also break stuff out into functions. You have lots of options. All right, so our pop quiz. This will never emit. Does anyone know why?
There's no consumer.
No, there is
We
consumer.
got console log consumer. Console log's going out right down there.
It's like because
Effectively,
that
skip value.
We're not mapping it.
we're not materializing any of the values, so we're not passing any of the values.
We're not materializing any of the values. We're just filtering.
We're filtering to a situation where nothing makes it out alive,
Yeah.
right?
Yeah, we're filtering, but it's nothing.
Effectively, in this case, we will skip value.
We're not mapping it. We're not materializing any of the values. We're just filtering.
We're filtering to a situation where nothing makes it out
Exactly, we'll filter when nothing makes it out of alive.
alive,
Yeah.
right? We're skipping values that are under 100, and then we're only taking
Exactly, and they're only taking is
values. Like, but because it's a pipe, you make like both those things. Like there are numbers between 101 and 499, right? But only they basically nothing will make it out into the next one, right?
exactly until
So you
the
have to be very careful that your pipe, every value passes the next one. Not a set of rules that all run in parallel. It's each stage, right, only lets a certain number of values through. Cool.
So if we make this particular example here, right? Well, I already did that. I just want to now is so to transform is this. Okay. So based on the following example, like this, right? So based on the following example like this, right? That I would like to transform is this into now really again. Now, what do you think what you're doing? Okay. Oh, I get it. No, I get it. Let me see if this is real time. This is real time. This is real time. Exactly. So like this, So now we got this, all right? For example, we got the Fibonacci here, and then we want is to transform into a by saying is the pipe, right? And then you say, hey, I want to now is get the pipe here. So right now you're not able to see what I'm doing, but you will. There you go, you are. So I just created this exercise here. Say, hey, Fibonacci .js to actually explore that, right? By saying is, hey, let's go to explore this Fibonacci, which means is, hey, I want to create an observable here of an iterator, which means using is the from Fibonacci, and then pass now some sort of stop condition, and pass a stop condition from here. So I want to create now this observable. Okay. Let me see here. Yeah, example observable here. So if you, for example, now pipe this, say, hey, dot pipe here, you extend that functionality from that, and then you say, hey, skip while we're now skip the first end values, giving a condition here. You say, hey, the value of that will be now the value. This is the predicate. Value will be greater. Ignore the value as long as they are less than 100. That's right. And I want to then take another one. So I say take while like this, and say, hey, now give me is the values, that are greater than 500, right? So it means here that this won't never run. I mean, if you're saying, hey, skip the first 100 values, and then now only take those values from that, what will be the expected output here? It's like, well, you are now is returning something that is not to there, so it won't, at least it won't do anything from the beginning. It shouldn't do anything, by the way, right? So if we now save this and run it on the index, from, and then we want to subscribe to this, say example.subscribe, and pass the console log here, right? This, of course, is not going to show anything here, because as you might see, you have to be careful of the condition that you pass through all of these functions, right? So for example, you might say, hey, what if I pass here 1000? It will never print that out, my friend. So if you say, hey, skip the first 10 values, and then take now the next 50, you know, your condition here is important, because you will never get out of that. You will never get is the value that you want to. So in fact, if you say, hey, skip the value that are less than 10, then you're gonna get all of those rest values. The other is, hey, is take while, like so. You say, hey, now give me is those values that are greater than 50. Perhaps you never reach to that. That's right. You may say, hey, give me the values that are less than that. And here is when you take that. Yeah, you have to be careful, especially of what is the condition, what is the series of steps that you're gonna pass when you create your observables or the operators of the
Only
observable.
about all 100 of them. We're going to talk a little bit about some of the common ones, and some of them I'll just sprinkle in as we are building things, right? But we can kind of see some of them as we kind of go through. So we've got filter. Filter does exactly what it does with arrays. It filters them based on the function. So in this case, only even numbers will be allowed through. Map. Who doesn't love a good map? Possibly midway through this workshop, you'll hate map for reasons that we will talk about later. Some people who have a little bit of experience are smiling and nodding. The rest of you will arrive at that station together. Map will go through the values and do some transformation to them. This works great for regular values. I will just kind of give a little bit of a spoiler. It becomes problematic when I heard you like observables, so I put observables in your observables. And that's where we're going to have to deal with some of that, but we're not totally there yet.
Map filters,
It's got a little cousin called map2,
map
which
to.
just maps it to a value. Map2 basically is effectively if you took whatever value it was and returned the same string no matter what, map2. Cool. Reduce. Reduce is, there's two that are kind of similar, right? Reduce and scan. I want to point out the difference between the two of them. We'll look at scan next. Reduce will basically be like an array reduce, very much so, where you will only get the final value when it's all done, right? So it'll work through all the numbers. In this case, it's totaling them up. It will add them all in place, and then give you the final value. Scan will actually give you, every time it runs that reduce function, it will emit the value and pass it through, right? So if you want every kind of totaling them up, it will add them all in place, and then give you the final value. Scan will actually give you, every time it runs that reduce function, it will emit the value and pass it through, right? So if you want every kind of piece as you go through, every value is emitted, you'll get it all along the way. Reduce will only give you the final result. So the reason that I point this out is scan is usually what you want, what your brain a lot of times, because of arrays, will think about reduce. So I'm like stopping for a minute and pausing to be like, no, you probably want scan, even if you're thinking reduce in this case. Scan can theoretically, you take an infinite range, you can scan through it, but what you want, what your, it will add a piece as you go through. Every value is emitted, you'll get it all along the way, and then give you the final value. Right? And next. Reduce will basically be like an array reduce, very much so, where you will only get the final value when it's all done, right? So it'll work through all the numbers. In this case, it's totaling them up. It will add them all in place, and then give you the final value. Scan will actually give you, every time it runs that reduce function, it will emit the value and pass it through, right? So if you reduce scan is usually what you want, what your brain will, you're thinking reduce in this case. Scan can theoretically, you can take an infinite range, you can scan through it, but then you take 4, so on and so forth. One final one, which is everyone's best friend, is tap. We said before, pipe, one value, to the next value, so on and so forth, right? Tap allows you to kind of have a side effect for a second and then return the same value you received. Why is this useful? Because if you don't have tap, here's what you're going to do. You're going to map where you console log the value and then return the same value again. You don't need to live like that. You can just use tap, and you can console log the value. It's also useful for side effects that you want to do, because again, your subscribe will only get that final thing that comes out. It will not get any of the intermediary values, right? Yeah.
Am I understanding correctly that top is essentially a convenience function where it takes in a value, operates on it, and returns that same value?
Yep.
Yeah, okay.
Exactly.
So tab is operating on the same value.
It's like, I want to do other stuff, but I don't actually want to change this value in any way, shape, or form. Keep it going through. I just want to, again, console logging alone is worth tap's weight in gold, even though it's code and doesn't have a weight in gold. But yeah, tap is useful for, I want to do something, a side effect of some sort, right? Because this pipe is, in function.
Okay, tap is useful for some sort of side effect.
Programming, like it's a pure, it's a set of pure functions. Tap allows you to have a side effect. That could be console logging. It could be manipulating the DOM. Could be anything along those lines. Anything you need to do that's not going to be the final value can happen in a tap. So your mission is to get comfortable with some of these basic data manipulation operators. We have a kind of a series of tests that we're going to go through just to kind of like understand and see. Just again, like I said before, sometimes the syntax is a little bit different from what you might be used to. So this will kind of allow you to get a little bit of muscle memory and some understanding around that as well.
Muscle memory. Let's get into this, man.
So with that, let's go and take a look.
Okay. Basic operators. The tests. Let's take a look at that, my friend. And that is basic counter. Basic counter where we are. Exercise. Basic operators. Oh, basic operators. Here we go. Basic operators. On the exercise. Okay, basic operators. Oh, makes sense. Oh, makes sense. All right. Wait, this is not basic operators. Oh, and how you can create this kind of stuff. Okay, basic operators. Return new observable, new promise. Okay, where you're going to now is return is a new promise. Okay, that it will now is just push those values into that and call now next with these new values you pass it, and then the error reject here and then complete. And once that is done, okay, you're gonna pass that. Returns all the value emitted by an observable as an array. I'm tired of typing this out for every test. And return all the values emitted by an observable as an array. So it means that hey should take the first value and maps them to the word dinosaur. It maps them to the word dinosaur. Well, here's where you create your observable of that, and then you pipe here and say, hey, you know what? You say, hey, skip. All right, skip the first one. Should take the first value and map then to the word. Oh, okay. You say, hey, take the first values, right, and then map to the word dinosaur, right? Say, hey, dinosaur. And if we run this piece of code here, we say, hey, not sure how to run this code here. Wow, what the French stuff is this? Okay. Anyway, so package JSON, test, just watch. Okay, so you say npm test, right? You watch this, then you skip, but I don't want to skip. One was to skip. I want to is do this. That's right. Should take the first values and map on the word dinosaur. Pretty much like that. It should skip the first 5 values and double last 2. Okay, so here you can say, hey, let's going to now take the first values, the first 5 values and double last 2. You say, hey, then I want you, each one of them, I want you now take that value and double last 2. And double last 2. So take the first value and double last 2. All right. So take the first value and double last 2. And then you say, hey, skip the 3 ones, the first 3 ones, and then double last 2, which is the last 2 would be is this, and double last 2. And then double last 2. Four and 5, and then double them. What? And then double
So
them.
with a thing in a array, and then we'll return the expectation, it'll wait for the promise to resolve in this case. So it's just syntactic sugar over what we did by hand before. And in the interest of time, that was cool when we were trying to get an we're good for times. So what are the 2 operators? If I only want 5 out of the 7 items in this take, 2, 3, 4, 5. And now I really have 2 options, which is a little bit. Like there are some, and then I can figure out is the counter running or not, or what the desired state is, rather than going like, oh, it's the event from this event target, this, right? Just map this one stream to true, map that stream to true, false. When I get them both together, I will handle my stuff. So that's the kind of, if it feels silly in this example, it is silly in this example, but like the answer, this is one of those ones where the answer is kind of in the question, right? If take takes the first 5, skip will, in this case, skip the first 5, right? So in this case, we can go ahead and we can skip 5 of them, and then we will map, and map takes the value and it says what do we want to do with it. At this point, we just multiply it.
Yeah, but say should skip the first value and double the last one. So should skip the first values and then double the last one, which is whatever value you get multiply by 2. So when you skip this, oh, what the French toast? Exactly.
By 2. Awesome. All right, let that pass.
Should it
All
be
right,
the
so now
square?
we're getting a little bit.
Should it be the square of every even number in the string? Okay. Okay. So here we're going to evaluate as a condition.
We're escalating a little bit here. We want to emit the square of every even number in the stream.
So this is now a condition that we can apply. So let's take a look at this condition, which is skip or take while this value here the value here is now is an even number, exactly, which means that, hey, is this value model is 0, the value of model 2 is 0, it means that it is an odd number, an even number. All right, yep. Okay, should it mean the square of every even number in the string? So now, well, I want to now take each one of those values from this and emit the square of this. Say, hey, value times value, which is this. Or I think we can do something fancy here, or something like this, right? So the same thing for here. So you're gonna take it's only 2, 4, and 6, and then double that. 4. Oh, and then the square. Yeah, the square. Then 4 times 4 is 8. Should be the square of every even number in the string. Say po. Okay. Okay. Which is now I say, hey, math dot pow of that value and this value. So when you run this, okay.
Right, so we want to kind of ignore the odd numbers, and then we will multiply the even numbers by themselves. What do we use to ignore? I guess it's really glass half empty, glass half full kind of thing. Either ignore certain values or only allow in other values. What's the operator for this one?
Filter.
Filter.
I use is now take while and then map each one of them. Another is that filter. Filter all of these values and then now apply that.
Not even, then it.
Oh, no. Filter.
We'll only allow the even ones through, and then which point we can then.
Exactly that. Only allow even number if it's true. Okay, exactly, because okay.
Map. All right. All right, it's passing. Cool.
But it's because filter is now applying it all of this
We'll unskip that test
to all of these elements.
as well. All right, it's passing. All right, so we
Of
want
course.
some of all the total Fibonacci numbers under 200.
Should sum of the total of all the Fibonacci's under 200 numbers under 200. Here we can use this now. Take while. Okay. Take while those numbers. All right. Take while those numbers are less than 200. All right, and then scan that. Redux give you is the last number, and then scan each one of those elements. For example, the accumulator here. And here we are looking at that Redux. Redux. You say, hey, this is the accumulator and the current value. The current value then you say, hey, the accumulator plus the current value followed by the seeds, which now in our case start with 0. So if we skip this, it actually worked as expected. Should merge each object emitted into a single object, emitting each state along the way. Should merge each object emitted into a single object, emitting each state along the way. So okay, and here we got this with another object here.
So, which which will then shoot a value through that observable stream in the very beginning. There's also end with, right? So you can have the first value and the last value that go through no matter what, regardless of what that observable does by default. This could be useful if you have an input field and you might be like, cool, like nobody's typed anything, I don't have anything to work with here, shoot through the initial value, something along those lines. So start with is another one that we can use. I don't know if I have it imported, so that might blow up.
Does the reduce function work like array reduce, where if you don't pass a second parameter, it just uses the first and second values together to combine?
I think the first value goes through. Yeah, the first, and then the second value would be the.
Yep.
The first value goes
and
through.
where reduce and scan can be somewhat interesting is it's one thing to total up some numbers. The other, with scan, you think about you can take an object, right? And then as things go along, as let's say actions, if you want to call them, go through the stream, you could take that object of state, take the object that comes through, and figure out how you want to augment that object, and effectively create a Redux reducer out of the box. So this could be interesting. If our counter got more sophisticated, and we're like, okay, by what interval do we want to count up? How, like by 5s, by 2s, by 1s, at, what rate? Every second, every 5 seconds, up or down? What we could do is, if you've ever used any kind of like Redux Flux-like data store, you could theoretically use scan as every action comes through, manipulate the final state along the way, and you'll get every state transition, right, as you kind of go through as well. So that's where this can become somewhat useful as well. And what would that look like? Well, here we would have a pipe, and we'd say scan, and in scan we'd have the current state, and next, like this one's not using like actions with payloads, it's just kind of augmenting the object in this case. And we could go ahead and do everything that was in that last object, and just overwrite anything that was in the next state. And we gotta put that in parentheses, otherwise JavaScript gets very confused. And in this case, we've basically built a mini version of Redux, just using the scan operator and passing through.
So it's like, by receiving this chunk of data, I'm getting now is construct this different new state of that.
Values, right? You could call this action. It would work. You just have to do the stuff you normally do in Reducer. Like if action type is whatever, then do this state. But yeah, effectively, you can do a version of Redux in just a few lines of code. So yeah, those are some of the basic data transformation ones, right? Starting with simple and you can see how you might use this to kind of manage more complex things.
Okay. Well, that'll be all for this video. Take care. Bye-bye.